Hey, all right, somebody sound check me.
Hey.
Hey,
Mm,
thank you.
mm.
Yeah, I got not much voice.
It's a deeper voice.
Yeah,
Mm,
back when I was singing.
mm,
Hey, Kirk,
mm.
in the choir.
You are recording?
Oh, I probably am. It's Hey, it's Coffee Compiler Club, and I have a raging cold. I'm not going to do a whole lot of talking, and my voice sounds like hell. I'm on all right meds, so don't worry about me. I'm fine, but it'll take a little while to recover here. Anything to do with compilers and language runtimes, and I don't know what. And I'm going to let other people lead if they want to, because I'm just like not talking much. That's it. That's my, oh, you'll be up on Twitter, your video talk up on Twitter in a couple hours. That's my spiel. I visited with my granddaughter in Philly, which is surely where I got my cold from. She's amazingly cute and has nothing to do with compilers.
Not yet.
Not yet. We're working on it. Both her parents are programmers though, so could happen. All right, Darrick, can we get a status report from you?
Yeah, sure. I don't remember where I was at last time I was here, but I've got end-to-end compiler running, at least for risk, and I've had that going for a couple of weeks. I haven't been brave enough to get started on the register allocation for the other parts, for the sort of PE array part, but I've been plugging away at various bugs and minor issues that I've found in the meantime. The biggest thing is I have this kind of interesting inside the PE array. There's this set of masks that our PE array uses. So, like for instance, so there's like a helicopter flying by here. Our PE array, it's a SIMD, so you give it instructions and every PE in the array does the same thing, but you don't always want 512 PEs doing the same thing. And so to deal with that, we have the ability to do masking both in the row and the column direction. And so you set up masks in different ways. So there's like a way of setting up row mask, and then there's a way of doing data dependent column masks. Each PE can turn itself off and back on. But it means that you can do processing on a variable or some data where some of the data won't be changed by that processing and some of it will. So I had to sort of figure out how to handle that in the compiler so that when I assign both the processed and the unprocessed version to a variable, that I'm actually still talking about the combined data and not, it doesn't sort of morph into two separate things. So it's not the same as a fee, because both sides always happen.
Yeah, but why is it not the same as a fee? You're just feeing out one of the results. You're taking the original value or the computed new value.
Why is it not the same? Well, maybe it is. It is quite similar to a fee, but I ended up putting in a merge. Well, one thing is that I have to keep track of what the masking is. And so the rules for getting rid of merges is I can drop. So for instance, if I do a merge, I can originate a fee against, or I can originate a merge against undefined. So basically I have to decide as a compiler what that means. Like I can, if I'm inside a masked block and I create a new variable, there is some part of that variable is undefined. And yeah, so
set it to 0 if you're worried about it.
But yeah, so that's what I do. So, and then I have to actually move the set to 0 up to the before that mask
Right,
block.
so it's fully defined as a 0, and now you're moving it a new value or not.
Yeah, yeah. So, yeah, so anyway, it turned out to be quite, I guess, quite similar to Phi, but I create the operation that I created for this is like a merge. And yeah, so far I've got that working. There were a few issues I had to sort of work through to get it going, but that was sort of what I was doing this week. Yeah, I don't know. I don't know. My fees don't have the mask information attached to them. I think it is, even if it's very similar to a fee, it's not quite the same. Also,
make it the same. Bring the mask down to the fees as another data value.
Masked areas don't have their own regions.
Yeah, but they could.
They could. Yeah, maybe.
I'm sorry.
What
The
would-
C2 and SSA, all other compiler people at the time were doing specialty exception check handling techniques and adding new check instructions and check ops and conditional blocking check or not. I turned everything into if tests with fees and whatever. Totally standard control flow graph. Worked great, optimized great, had one set of optimizations and semantic analysis for all things, whether they were user tests or Java bytecode tests, whatever. It was all fine.
Normalize the path.
One less path, yeah,
Normalize paths as much as possible.
yeah.
Makes testing a lot easier.
That's true too.
Yeah.
A lot of good carry-on effects out of that, for me at least. A lot of optimizations I did for redundant checks also covered redundant user level checks equally as well, which after inlining showed up also.
Mm-hmm.
I mean, I don't know if that's going to happen to you in your PE array, but
Yeah, well, definitely. My goal is to try and inline very aggressively any code that's happening in the PE array, and then be less aggressive and try and for anything that's happening in the risk array, the inlining is much lower priority because the ability, it'll be much harder to and much slower to sort of store data away from the PE array if I need to, make register space for function call. So like caller save or callee save registers in the PE array are going to be more complicated. So my hope is to just be able to inline everything in the PE array.
what do your PEs look like? The 3 address risky thing, or
They're fairly big for PEs. They've got a multiply accumulator, and there's so it's a byte. There's a register which is called the rotator cuff. We call it the A register. And when you do multiply accumulate, after every multiply, or when you do, GEMV, which is the matrix vector multiply accumulate, the A register value moves from PE to PE. So there's 64 PEs in a row. You can set up the rotator cuff. There's a register you can use to configure it, and then data can be moved in different patterns, including circular patterns. So you can do 64 op matrix vector multiply, where every byte in the A register visits every PE during that process.
so are these meant to be like a glorified DSP chip, or I thought they were doing like kernel net things?
It's kind of a hybrid. So it's not it could be used for DSP, but it's it's meant to do it's meant to do the operations that you can do in a neural net like efficiently, but it doesn't use quite the same primitives that a lot of the other neural net chips use.
Okay, yeah, I didn't know what to say. Interesting. Well, it can do a multiply, add, accumulate thing. I mean, they got anything else going on there, like opcodes for them to do stuff? The masking.
Yeah, it's a little bit lower level instruction set. So we have a bunch of registers that we can move data around within the PE. And then we have a mask bit that we can set. You can basically write into a mask bit. You can then use you can either ignore the mask, or you can use it masked or reverse masked. So you can like invert the mask as well. So you can kind of do if else, and then also do other stuff where you just ignore whatever's in the mask bit. So that's fairly flexible. And then there's about 20 bytes of memory that are attached to SRAM. And so you can actually read and write directly from those registers into specific pages of SRAM. It's a bit complicated to set up your data to be in the right place.
20 bytes.
20 bytes. 20 bytes of data can be loaded in registers in the PE, and then each of those can be, those registers are also used to read and data from SRAM into the PE. So if I read, it appears in one of those 20 bytes of registers, and in order to write to PE SRAM, I put the data into one of those registers and then write it to the selected address.
This is like compute in RAM almost.
That's what it is, yeah.
Okay.
Yeah. It's our architecture, we call it at memory, but just to distinguish it from in memory, where they're doing the computing literally in the SRAM cells.
Okay. Yeah. Okay.
So we're not doing any analog stuff.
I got one of these.
There you go. What is it?
Pin.
Come on.
Processor in memory.
Push it up to the camera more.
Oh, there you are.
Which
Sure.
oh,
Light, don't worry about it.
We built that ourselves.
Yeah.
And I put 32,000 of these into one box.
Oh.
There's single bit.
Oh, I see.
oh, those are the early ones.
Yeah, this is
Yeah.
with 94.
So I have a Zool box. My finger on the camera is pointing at a motherboard.
Yeah.
It has 4 Zool chips and 48 cores per times 4 on my camera there.
So we built about 5. We've built 5 of these machines.
Did you work with Martin Snellgrove at all on that?
No.
No? Okay.
No.
He was doing similar stuff around that time, one big processor and stuff.
Anyways, fun.
Yeah.
I have one of ours as well here somewhere.
I wouldn't mind working with hardware more. It seems really fun.
The whole different both mindset and time. The whole tape out, chip out thing, and then you wait mystery weeks or months, and then you get a magic Christmas day, comes back, and oh, it's dead from the factory, and you have to try again.
Yeah.
Yeah. I think it used to be easier because it took a long time, but at least it didn't cost millions of dollars.
Yes, and it costs millions for each shot.
Yeah.
Some upper level bean counter is sweating bullets, hoping that it comes back from the factory working the first time.
Yeah, well, I can tell you that startup founders also sweat bullets for how about that?
Yes. Oh yeah. Was there. Good stuff.
Yeah.
But of course, the first chip for Zool came up and we were just ecstatic. We had bad cross feed between levels of L2 cache. So we cut down the cache to one way instead of four-way associative, and it quit bleeding through. And a bunch of the clusters were dead. So we had like one good cluster because of the cache was so broken. So we could get 8 cores going, and we had electricity bleeding through the branch prediction into the registers. So we had to switch to using only even number registers and branches to odd addresses. And then we just changed the GCC compiler to say it was a 16 register machine instead of a 32, and gave them all even numbers. And then we changed all the branch offsets to pad by one 4-byte thing. And okay, that's fine too.
Yeah. And did you eventually respin the chip?
Mm-hmm.
Yeah.
That was the first cut. The other one is that in order to get the L2 is working as much as they did, they had to over voltage it. And this is where my physics lesson came in. When you over voltage it that much, like, and the coolant, of course, they have like huge cooling fans blowing on this, modest chip here. There's just huge tons of air cooling on the thing to try to, it's way over voltage, it's running super hot. You get electric migration where the atoms begin to move through the metal. The doping atoms are moving through the silicon substrate, physically moving, and eventually they short out. And so we were like, well, we could add a timer on it. They could do the electro migration test. They had a timer, they knew. We got about, 6 weeks worth of work on this chip, and it will sort out permanently forever.
Right. Planned obsolescence. Perfect.
Yeah, totally. Oh, it was fun. But then, we got it up at some point, and we had 24 cores. It was like insane. Couldn't believe it. Hugely more than anything anyone had ever seen before.
Yeah. Our chip came up on the first spin, but there were some parts that didn't quite work. We had to respin to a metal spin, and then it was pretty much fully functional. I actually did all the digital. I led the digital verification, and I had never verified a chip before, but we had no digital issues. All of our issues were analog.
We had a young intern find the one digital issue with the Stack Overflow handling on the stack hardware registers. Otherwise, it was all analog. A whole lot of guys sold us a whole lot of silicon that they made all these claims about that it was not true. And that was led to all our problems. We even had like power supply, like we eventually settled, like we bought 20 power supplies or 10, a bunch. There were supposed to be 2,500 watt power supplies. And the tech guys just put them in the lab and put a 2,500 watt resistor load on them, and they fried. This is a rated 2,500 watt, everyone fried. So we went back and said, defective, try again. We got a new set, all fried. We said, okay, guys, what the fuck does this rating mean? And they said, well, we didn't believe anyone would actually test with that load.
It's like those speakers, 10,000 watt speakers in a ghetto blaster,
Yeah, right.
There's some like weird way that they came up with the number and put it on a package. And
we settled on Fujitsu, and they agreed to correct it to 2,500 watts, and we ended up packing in, a lot. The thing ate power, but it needed a bunch of them.
Yeah.
Lovely.
Okay. If
All right,
we
Kurt,
don't have a topic.
Oh, you have a topic. Okay, I was going to great
No,
time.
no. If we don't have a topic, I believe Simon has a core update. I would ask him to, if you'd like to give.
That's true. I forgotten about it. Yes, so the long troubles regarding unified condition expressions are finally over, I think. In the end, the trouble was that with these conditions, you have many things all over the place called condition. And it turns out that if you have too many things called condition, you believe you have type checked all of them, but it turns out I only had type checked 2 or 3 in the specific function, and of course then nothing worked for a long time until I figured out that was the issue.
You have an example that'd be very entertaining, I think.
Maybe click on the first link, I think.
In the doc, sure.
Yes, and I think I can tell you where to scroll.
Yeah, I was looking for
Or
examples as opposed to,
Can you you
we
want
can
to share
share.
screen, or
yes, let me do that.
I mean,
Uh,
usually if I share, it's not that successful.
Okay, try now.
You
Hey,
who
Simon,
will
you should
share?
have-
Who
you should
will
be able to
share?
now.
Simon or Cliff?
No, no, I said Simon, I said it for public sharing, so first come, first
All
served.
right, okay, okay.
Let's
Uh,
try.
Let's try.
Yeah, should be. In theory, actually, it says multiple participants, but I just, let's be nice and do one at a time, but anyone, Simon.
Let me close everything else.
Well, don't share your screen, share your application. And then you won't get notification pop-ups either. All right, you gonna be getting that? Because I can try somebody else in here.
I believe he froze. On the
Oh, I
screen.
think he may have frozen as well.
Hmm.
Well, there you go.
Well, he will rejoin and resume. We can change topics for a
Yeah,
little bit.
let's do something else here. Anyone else want to bring a status update or some topic? Everyone's all quiet and I'm out of voice.
Levo.
Well, I don't know. People and I were having a discussion about some things on the Discord. I forget what it was, but
Oh, we're all hassling Levo about how fast this compiler is versus how general purpose it is.
well, no, it wasn't that. It was like something.
Was it the code smell and not using a language model?
Oh,
Well, that was, yeah, every microarchitecture on the planet changes every
well,
generation.
yeah, that was it. I mean, so like
Well,
from
yeah.
that thing.
Sorry.
So like it seems like it's very important to have an accurate like instruction throughput model so you can schedule your code efficiently.
It's not. It's not. If you're an x86, it's horseshoes and hand grenades. Close enough is close enough. Yeah, it's what's the right way to put it? You're stuck behind cache misses. So you just got to get kind of sort of close, and a decent list scheduler will do 99% of that. So it's nice to have a little bit of a model to feed into a list scheduler, but that's all you need.
Well, but that's where that's what the graphs, right? They have like 20% variance, and that was all because their optimal model that they were solving for was different from the actual hardware.
If you take a really tight micro benchmark, which does way more compute than memory, then scheduling matters a lot more. And you can spin like video codecs and the like, can spin up to insane numbers of throughput rates. But if you're looking at general junk C code or general junk Java code, you're always stuck behind butt tons of memory misses.
Yeah.
And you only need a decent execution, scheduling to get to where you're stuck on the next memory cache miss.
I mean, no, that's not what I care about though. What I care about is like, like, I don't know, FFmpeg, someone's writing their video decoder, inner
You
loop.
should bring up Unicode and get an optimal, instruction selection for SSMPeg.
Okay,
Yeah.
so during the conversation, I like to keep my paragraphs short because I know the more I write, the less people will read. So what I meant to say was like most of the time, I think 50% of the time you should be writing code. Maybe 20-25% of the time you should be reading stuff to like and try to like understand your code or the architecture or like whatever it is about the problem you're trying to solve. And then the last 25% you should actually be like measuring.
Hang on, Levo, this side interrupt. That's a good ratio all your life. Spend 10 to 20% every day, all your life, learning something. as
Yeah.
opposed to applying what you've learned, just as a general rule. Okay, fine.
Yes. So when I was like, when I saw Alan say language model, I thought it was like a joke, like he's just like messing around because it seems like he likes to joke around in Discord. But one of the things I didn't say was you could just use performance counters to like see where your where your code is going wrong. So you don't even need a language model. Like the hardware does it for you. So
Yeah, you
Well,
don't
no,
want to code the
but-
microarchitecture into the language. That's kind of
It's expensive.
All right, one at a time. So Ganesh first.
you don't really want to encode the microarchitecture into the language. That's kind of a little too far. It's not even
Oh,
encoded in the assembly, really. So
That sounds like a fragile pile of glasses waiting to collapse at any changes.
Yeah, I think that's
it's not even clear that it makes sense because it's not even exposed in the assembly. So
Hmm.
it doesn't even make sense to ask that question.
well, I think Darrick might be in that boat, but not anyone else.
Maybe that is a little slightly different because he's like a specialized thingy.
Yeah, he's got custom hardware. He's got to use it.
Even then, I'm trying to keep it general, and I have most of the really machine specific stuff in a late pass that sort of converts things to be actually machine specific and name.
People flag PE versus non-PE code.
Yeah, well, I use a type system to sort of gradually figure that out, and I actually found that for that I don't need a special stage. I just have those transformations in the grow phase of the ideal pass. By the time I get to grow, I know well enough that stuff is PE or not, and I can be fairly sure that I can make those changes. So sometimes they're not really growing, but it's just sort of late.
Yeah, they're late changing over to the PE. Sorry, Alan, go.
Okay, so I forgot what I wanted to say. I was reading the discussion. So, okay, so I wanted to clarify though. So Levo has been saying language model. So that's not what I'm using. What I'm using is a machine learning model. So it takes like a sequence of instructions and then it like transforms them. And then it gives you a number that's like the expected number of cycles that block will take. So like it's not like a language model, like, you know, chat GPT or whatever, where you ask a question. Yeah. So it's machine learning, but it's different.
The input sequence of source, output, expected cycles per instruction, or
Right.
optimal placement of code.
And so the place where that goes is it goes in the compiler when it's deciding how to transform a sequence of like, you know, source instructions. It says like I could generate this sequence, or this sequence, and then it runs the model and it says which one is faster. And so and you don't want to actually like compile them to source code or to a machine code, I mean, and benchmark them directly. Because benchmarking, you have to set up all the compiler stuff, and you know it takes a while to get into a benchmarking mode and get good results. And so if you use the machine learning model instead, then you can just run the model and it, you know, it's, you know, crunching numbers, and so it's easy to do as part of compiler workflow.
Do
Yes,
you use
saw you
machine
posted
learning?
that, and that's less accurate than the machine learning model. That's what they showed, is that modeling the microarchitecture is stupid because it's too complicated. And you can
So
just
that might be true for people that are not like Intel people that have access to the internal micro, because they have performance models internally, right? So I don't think you need machine learning. You only need it if you don't have access to what's actually.
Well,
I didn't say modeling the microcode was stupid. He said it's not the lowest hanging fruit to be the next thing you should do.
yeah.
We have an example where like we made some change. It came up with a regression on one of the tests. After analyzing the regression, we literally moved one move instruction like 2 instructions down. And we had no idea, like 15% slower performance. And we reached out to Intel folks and they're like, we have no idea. It should be the same. So even having all the information, sometimes they don't know why.
Depending on, yeah, I mean,
Get
also
cache
weird
layout, your hot loop spans a TLB boundary and it doesn't prefetch across the boundary, and never mind,
Yeah.
I have no idea. There's some weird shit there and it gets complicated enough.
Right. I mean,
So-
that's these are so complicated that machine learning is actually the simplest approach to modeling them. Is like, you know, oh yeah, this really is a giant black box, and I have no idea how it works.
If you're Intel, you have to have the model to try and make a guesstimate of what it'll turn into when you build the silicon and write the chip. But if you're a consumer, yeah, maybe you don't need more.
While thinking about that, it makes sense. But wouldn't performance counters be easier to understand and figure out?
Well, no, you'd use the performance counters when you're trying to as the inputs. Like those are when you're coming up with the training data for the model. Like that's probably what you'd train on. Is
So it's source and
performance counter.
Interesting.
So how are you creating this model? Because I'm hearing this, it sounds like equality saturation to me.
Oh, no. So, well, equality saturation is like when you're coming up with the instruction sequences. Like this is just it's a very simple, you're saying how much does this cost to run the sequence of instructions. And so there's like, it's called Ithemal, ITHEMAL. I'll post the paper.
Say, put the link in.
Yeah. And so like it's a transformer model. So it is kind of similar to ChatGPT. It's like they take the
But the model, just you already have the sequences and you ask it.
Yeah, you have a bunch of sequences with measure and the results of measuring them, and then you train the model and it can predict new sequences of instructions.
Do you have cache misbehavior trained into that as well?
I think all of these assume that you always hit an L1, otherwise it's kind of difficult to.
Well, that was my comment about horseshoes and hand grenades.
Yeah.
If you're not
so like
always in
obviously,
L1, all this shit doesn't matter.
Yeah.
Well,
I mean, there's certainly high level heuristics there. You know, when you're trying to get someone to not have lots of cache missions, you just tell them allocate less. If you have something that looks at a piece of code and says, well, how often does it allocate? If it allocates a lot, it's probably slow. If it doesn't allocate so much, it's probably fast.
Woodley.
Like heuristics can get you a long way.
Yeah. That's one of my first picks on why your code sucks. Hey, let's look at the GC. Oh my God, you're drowning in allocations and bandwidth loss. And your GC cycles are quick and fast, and you're allocating bajillions a second. You're out of bandwidth. Quit allocating.
Yeah, there was some guy who did a talk on a character, and he like goes and opens Chrome and types an A in the bar, and then tries to measure every allocation that Chrome does as a result of the fact that you put a character into the bar.
That's hilarious.
Long story short, you cannot find them all. There's not enough instrumentation in Chrome to do it.
Wow. That's crazy.
How many neural nets run in that character just to try and figure out what you mean?
Yeah, are you suggesting aardvark next? Or, a chicken soup recipe?
That's true. Once it does network traffic, some of those characters are on computers you can't even see.
So we have a customer that we're dealing with, which is highly obsessed with P99 data. And I don't think they really understand what that represents in their system. And what I think that they actually end up doing is creating what I'm going to term as what I call noise resistant code, or code that is not disrupted by noise as much as other code. And so what I find is that code that's allocating a lot is actually more susceptible to noise than code that doesn't allocate a lot.
That makes sense.
And there seems to be a number of activities and things that they get involved with that actually accidentally lead them to these algorithms that are less susceptible to noise than other ones without actually really, because they think they're reducing noise by improving the performance of their application. But, since most of the noise that they're dealing with is external to the application, it's sort of like, let's change some code to reduce the noise. Yeah, it makes no sense.
Yeah.
Right. but when they do get success, it's like going like, okay, so what did you do here? and what did you take away? And I don't know, you know, and how is that susceptible to interference from other shit going on in the machine, as opposed to, yeah.
The
Yeah.
benchmarking without statistics.
To be able to make causal like things, you need like a extremely clean environment without anything else going on, and then only then can you.
But if you expect to deploy in a noisy environment,
Yes,
you actually need a
yes.
different
Yeah.
pattern to go. Yeah.
Well, a good,
No, I mean,
High frequency trading people, they try to make their production clean as well. So that would be the first step if you actually care about this P99 thing, to get that
well,
clean.
yeah,
And you really
so-
have to understand your platform to
yeah.
understand that,
Oh, yeah.
though. There's an example from cryptography. They wrote the JS crypto libraries, and they did everything with XOR math, because if there was ever a branch, you would use more voltage on one path and less voltage on another path, and you'd start leaking your keys. And they wanted everything to be time invariant, path invariant. You run the exact same code no matter what the key is.
I set a bit for that.
And this worked for several years until one day V8 got smarter in its code elimination and would realize that some of the pass-through or XOR logic were dead and some of them weren't, and would clean it up and reinserted all the timing attacks back in.
There's even something slightly.
So much for your branchless code.
Even if you have branchless code, I think on ARM or Intel, you have to set a certain bit that says that you want timing independence. Otherwise, even if you don't have any branches, they could actually be different timing. Like
Yes, you have to tell the CPU that you want timing invariant, or it will pull its shenanigans and reorderings, and suddenly the voltage on your CPU is going to start leaking your keys.
I threw the paper out that I believe was the one that did the change in execution speed based on the name of the author. The student and the professor had different length names in their
Oh,
environment.
I know this one.
But that was just dumb luck.
But they found it. So I might have missed it. I got
But
one, two of these papers.
That's actually not dumb luck. It's weird. I mean, it is and it isn't, because this alignment and memory thing actually becomes extremely important. I mean, I actually got embarrassingly caught out in the talk at this fight, because I was demonstrating a JVM optimization, and of course it worked. Before going into the talk, I did the talk in the talk, and I said, and look at this wonderful optimization that never happened. And it was very annoying. And I got out, and as soon as I could get rid of everybody, I just, got outside, and I just figured out, like, it was memory alignment. It was just basically, I had my presentation software running during the talk, and I started, the optimization never happened. And when I turned it off, the optimization happened perfectly. It's all just down to. So now you just like write a big chunk of C code that just basically says, grab big chunk of memory, however big you want it, and you push the program around the memory, and you keep running your benchmark, and you can see you can get like somewhere like up to like a 40% difference in performance, simply on how you can accidentally get your program aligned as it gets loaded into memory and stuff like that.
Do we know any stories of JITs deliberately doing those kinds of experiments?
No, they actually don't. They don't deliberately do any of these type of experiments. So they keep running the same bench over and over and over again, and going like, hey, we're getting the same results. So yeah, of course, you're running the same experiment over and over again. I would expect a variance of 0 there, devoid of, in an environment devoid of noise.
I was well aware of this issue, and it was always in the plan to go do something, and never got around to the time. Prior to Sun, I had observed flopping link orders causing 20 to 30% changes.
Yeah, wasn't that JIT can recognize a linked list, so it tries to hold its pointers closer together in order to not lose performance?
Some GC algorithms at some point tried to recognize you were doing things in a linked list. Some benchmarks were strongly affected by this. one benchmark was strongly affected by this. So there's a lot of screaming and yelling of this
Like
is
spec
awesome.
JVM, right? The most useless benchmark on the
It
planet.
wasn't spec, but it was a follow-on. It was right after 95.
Okay.
It was the set of benchmarks that came after 95, before like DeCapo. Like there was a 2000 set.
Yeah.
Anyhow, yes, it was right in there. And fine.
And-
Way more time was spent making those benchmarks go fast than was helpful to anyone on the planet.
Well, it makes money if its benchmark goes fast.
It's marketing.
Marketing rights, shouting rights.
Yeah.
Yep.
Just make
Well,
sure
this-
your window of measure stops before anything bad happens.
So I
I
wanted
mean,
to ask
I don't know. There were a bunch of dumb benchmark wars, but also during the years that the benchmark wars were going on, the JVM got a lot faster.
I claim that I was doing general purpose optimizations that I knew would also hit the benchmarks, but I was in my head thinking, this is general purpose. It'll help everybody. I couldn't morally only do the benchmark hack, except when I got explicitly told, do the benchmark hack. And I did a few of them, yeah.
Yeah. So we have some EA work going on now. Remember it was a number of years ago we talked, I think at, I don't know, Code 1 about more JIT optimization. So we're getting more JIT optimizations now. We're getting about 10% improvement now with better stack out, better escape analysis leading to better scalar replacement.
Yeah, that would do something. Yeah.
Yeah. So the first round here, which is just some branch merge, is actually giving us about somewhere between 5 to 10, depending on the bench.
Okay.
Right now. So it's pretty decent. I think we have another 30 to 40% in there at least.
Is it for hotspot?
JIT alone?
Sorry?
Is it the hotspot?
Yeah, hotspot. Yeah.
But from the JIT alone, not from.
Yeah, and I mean for the benches, right? You should get about 30 to 40%
You're
improvement.
thinking you're gonna get 30-40% out of the JIT.
Yeah.
Based on things like escape analysis would be the last in my head, the last big frontier that has big gains in it. But
Oh,
that's
there's huge gains there. Huge gains available.
okay, fine.
You don't think?
Well,
I mean, there's more gains there in the modern way people write Java than the way people wrote Java 15 years ago.
Yeah, except for
There's a lot of these little like options and things that you really don't want getting out.
So the biggest, so what I see is the emerging trend in terms of like a hottest allocated object, aside from string, in Java now is optional, right? And the JITs do nothing to like strip that out, like unbox it.
Well, how is supposed to save
If
us?
only there was a way for a pointer itself to indicate that it wasn't pointing at anything.
All right, Ganesh,
Right.
you let Ganesh go.
Yeah,
What background do you, Simon? I remembered.
it's quite ridiculous because, you know, like optional is showing up in JFR profiles, and JFR profilers are notoriously biased towards large allocations. All right, so we actually did a study. We got the chart. It's like, you know, if you have small allocations showing up in a JFR profile, you can practically say it's about somewhere between 100 to 1,000 times more prevalent than what JFR is reporting it to be.
Option allocating always allocating an object.
Yeah, optional is being allocated on heap.
However, can
If
it
you return
replace?
an option and you didn't get inlined, you got allocated.
Yep. Even if you got inlined, it's still being allocated. It's not being stripped.
When Valhalla finally comes, maybe this will be. I think it's marked as a value object. So eventually, when the Valhalla lands, it won't be okay.
Let's see how many people synchronize it anyway. Synchronized on it
I
anyway.
think they're willing to break the synchronizers, especially since it's already documented that way. Who knows? Let's see.
Anyways,
Levo,
emerging trends.
the question, Levo.
Yeah, I had a few, but I'll let other people go first.
Go ahead.
Simon
And
got
next
put off
Simon.
for a big
Okay.
crash. You ready to go now?
Yeah, well, guess which programs I closed when I cleaned up my desktop. All right.
That hurts to laugh. I can't do that.
Let's try this again.
We're fixing JFR, by the way.
Does this work? Do you see my code?
Yeah.
Excellent.
Yeah.
But
Like
increase font
Black,
size,
yeah,
font
yeah.
size.
let me see what I can do. Like this.
Better.
Yeah, and in the end, the one line I was missing was this one above, and without this, the core part of the unified condition wasn't type checked. I didn't have a register allocated. I used the wrong register somewhere else, and then everything fell apart.
Cascaded from there.
And
Yeah, right.
and I debugged through it and took some steps back, as people suggested a while ago, and that led me to the right conclusion in the end. So I'm not complaining, and I think if we scroll up there also are there some pretty code examples.
So without that statement, you just forgot to visit a huge part of the tree.
I forgot to visit this part, so like one of the crucial parts.
Yeah, okay, right. That node is if value and then dot equals. What's
Exactly, and
zero I32?
it's a number literal for 32-bit
32.
integers.
Okay.
Because int 64 is the default. So yeah, I'm forcing code to annotate the cases where we use 32-bit integers.
Why aren't you writing this in another language like Java? Just out of curiosity. Because it's more, I think Java, C# and a few languages are pretty readable, and I'm struggling to read this.
Well, he's showing his core language, not the implementation of the core language. We were looking at the implementation. Now
These are
core
tests in the
Oh
language.
no, I meant earlier, like with the node and the 0U32 and.
Well, 032 would have been. So yeah,
like I understood it, but I mean,
you had an example of core that said 0I32, but that was core, Levo, not Rust.
Yeah, exactly.
Said it's a literal, integer literal.
The default literal 0 would have given you an int 64 0. He needed an int 32 0, so you had to annotate his little, like adding or putting a leading U or a double LL after the end of a long number or whatever.
No, I can't find the.
Well, search for 0I32.
Oh, that's good.
no, it's okay. I was just like thinking because I wasn't sure if this was like your language or if this is the compiler code. But either way, I was just
both kinds of
off
files in
this
this screen.
Yeah, this is the language code now.
Yeah, exactly.
Usually it takes me quite some time to be able to read another code base. It's just syntax and styling just so different from what I'm used to.
Because of my old head getting the pattern match of what you intend and ignoring
Did I
syntax.
saw a pattern match destruct an object and bind its variables? Like
Yeah, that was, he missed those discussions. We had a lot of talk much earlier about doing crazy pattern match things, which actually look pretty cool. And you had more examples of your pattern match. And then the bug in the compiler was you didn't visit the pattern on the pattern match. Yeah, there's someone by right there.
Let me see. Right. Yeah, so the pattern matching exists, but it's not something I've written myself, but I just integrated the existing functionality into the new code. So, I mean, sure, you can have like the ifs with like normal expressions that just keep going like here and here, but you can of course also pattern match on, for instance, this ether type with a left and a right.
You can destruct a hierarchy.
Yeah.
Yes.
So Actually, I'm curious about the bit that we were just looking at. You just scrolled it off the screen, but there, that middle block there, if check dot 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 is false, one is true. Why is there an else?
Because check returns something else.
No, because I'm also testing messy code, and in this code, this file basically documents that the exhaustiveness of my expressions aren't checked. So it requires an else condition in this case, because it cannot tell that comparing a Boolean against false and against true is exhaustive.
But your
So-
intent is to make this eventually fail to compile?
Yeah, exactly. I mean, like the you can basically spend unlimited time into and go make your pattern matching exhaustiveness checks more perfect. But I think I mean the plan is to try and get like the easy 80% working, and hopefully that's enough.
The test
I was
right
planning
above
to.
does an ABC and a BCD. It's clear that, you know, you could be exhausted without too much more work there.
You get
I was-
enums. I think that's mostly enough.
Yeah.
What do you do at runtime if a pattern match falls to default, but no default is defined?
I think it panics. And
Oh, I thought you would not compile it. You demand a default.
yeah, I
Well,
mean,
you do
if
your
it's-
best to not compile it, but there's always going to be
Yeah,
something
exactly.
for
Yeah, I mean, yeah,
incompleteness.
I like ideally it doesn't compile, and I have some from the existing code base. There are some checks and some test cases where it demonstrates that it doesn't compile. For instance, in this case, it's clear that there is some exhaustiveness checking going on because we don't have an else. And if it compiles without an else, the compiler knows, okay, this is exhaustive. And
that's because you used an enum.
exactly. And for non enum code, it's of course like harder to think about the okay, what are the obvious patterns we want to detect and maybe support, and which ones are not relevant. Because I mean, like for instance, this pattern, okay, I have a Boolean and I do checks against false and true. No normal code will ever be written like this. So
so why bother optimizing it?
no, exactly. Yeah. So probably this will always require an else, because I will not spend explicit effort on making the compiler able to figure this out. I mean, at first I'll be happy if all the basics work, and like the compiler knows, okay, Boolean can only have two values. And for instance, like how is a string built? And if I have one instance of a string, that leaves like all other strings still unmatched and stuff like that.
It's not maybe entirely decidable, because if you rely on a runtime value, you cannot exhaustively prove that you cover out.
Yeah, exactly. You can sink an unlimited time into it, but it will always be a conservative approximation.
And it's
That's
hard
what I
to
want to ask.
Oh.
I haven't done switch statements yet, and I was thinking maybe I should do pattern matching instead. But is pattern matching like significantly harder, even if I want to do something very basic?
I think there is like, from the conceptual point of view, there is like a little difference in what you're doing. I think it's like, usually if you say you're doing a switch, it means it's a very, very limited way of pattern matching, and that is of course easier because you're basically not doing all the hard parts.
I would say the switch statement deals entirely with values. So That's its main case, but the pattern matching expands the capability of what.
Oh, yeah, expansion's fun. You know, you could start with pattern matching basically in an alternative switch statement syntax, and then just start adding features to it as you found time and energy.
Yeah, that would also be my advice. Start with if then else and keep expanding it with the things you think are important.
Would you build the pattern matching into the compiler, or is it just some sort of macro expansion that you're gonna sort of do pre-compilation?
I would make the parser keep taking larger, more interesting syntaxes, but every time he's going to spew out standard IR for a series of if and else's.
Yeah.
There's no
which I would
macros in my language,
call
and I'm trying to keep macros and special stuff to minimum, and I want the compiler to have as much information about what you're trying to do. So having defines, macros, and other things would kind of I can't say the word.
Well, this isn't a pound defined C macro. This is the parser syntactically expanded. Like you could take
Lisp.
Yeah, the let x equals.
Yeah, I mean, many Lisps implement something like this with macros, but
like anything the parser does to expand things as effectively a macro, even if it's not actually a user macro.
Yeah. I'm always I have only some concerns about doing this as a macro, because it's like, to me it feels it might obscure debugging and understanding of things if you are using macros yourself, but this thing is also a macro. I'd be concerned that you have multiple sources of compiler generated code clashing together, and it's hard sometimes to tell where things come from. And usually I say that the language should not reserve power for its own. So basically there should be as little as things in the language as possible that cannot be done as a library. But conditions and loops are like the two constructs where I say, okay, the compiler is allowed to have first class insight and knowledge into what these constructs actually do.
But if you're doing pattern matching, like what additional, like what do you gain from having special sort of support of pattern matching or something in the compiler?
You mean represented in the tree, Darrick? You mean like representing the pattern match in the tree, or?
Yeah.
So you need to keep to track the cases. There can become much more complicated if you try to unify the type. If you try to deal with the type with each cases, I believe there can become much more complicated. If you introduce variables, which arguably it's not the best feature, you can get away with it if introducing in a case statement a new variable. So
also,
are you talking about the user introducing a variable or the macro expansion type?
If you bind, you can in Scala, for example, in each case you can bind a new variable inside it.
Yeah.
So we.
Yeah, I'm just curious. Like I don't see a benefit to having that sort of moving that later into the process.
It becomes much more handy if you destruct an object of case class and you introduce a variable for each of the parameters in the case class in order to work more easier with it. That's its more powerful case, I would say, at least to me. You are destructing a case class that inside holds another information, and you extract that out from the pattern match. You don't deal with you test the case first, and then you try to extract its variables. It's doing the two at once.
I think we're slightly talking past each other. Maybe I think the question may have been, is it worthwhile to preserve it, like in the compiler, preserve the notion of a switch further down, or to break at the start? It doesn't really matter.
I gave my thoughts to you. You still have to want to represent the pattern match as an AST inside your compiler.
Yeah, I mean that it makes sense to preserve it because you probably have a lot of analysis you're doing on these things. But even I mean the question implies that there is some more primitive AST that's this switch is getting desugared to, and I think that doesn't have to be the case. For instance, I mean, there in my approach, there is no more primitive representation of these unified condition things.
You don't have if else?
Sorry?
I think from what Cliff was saying, he just desugars it into if else.
It isn't if then else. There is no other representation. That's what I want to say. There isn't if, there is nothing else.
It doesn't matter too much, I think, which one you choose, but
it's interesting because at the beginning of this call, I received fairly unequivocal advice to not have a special sort of representation of these merge nodes, and I should try and fit that into the concept of a fee. And meanwhile, here we're talking about taking a far more complex structure and saying, well, let's not represent that as if else's and various other statements that it could be broken down into, but rather represent it directly and have compiler transformations.
I think for Simon, he only has this one, so I think it makes sense for him. He doesn't have multiple versions, which I think was the main thing that maybe.
Yeah, there's like there is no simple if then else in the language. It's like an if then else and that's it. And yeah, your simple if then else might be one where not sure, you don't have any cases here, and that's basically it. But it's the same code, it's the same analysis, it's the same representation all the way down.
Okay, so this is my thinking on the problem. Let's just say we're talking about a switch statement. If you represent a switch statement as a series of ifs and else ifs, then you're going to have to write an optimization pass to convert it to like a jump table. But if you have it as a switch statement in the IR, it's super easy to like generate better code.
Okay, wait up. There are limited circumstances where a jump table makes sense. There are code.
It's just an example.
No, but I'm saying, do not change your language based on the assumption that you're going to use a switch, a jump table, and it'll make your life better. Because they're so rare usage, do not torture your language.
I mean, you even have WebAssembly where nothing of this matters anymore because you're not generating any jumps or anything. You're just adding the if then else to the WebAssembly file, and that's it. So.
Literally the other day I was looking at my switch code and it was a jump table. Like this is the code that C compiled, not
there are uses for jump table switches, particularly in parsing. But they're actually in real life relatively rare. And a jump table has an actual cost if your set of options you're picking between is modestly sized and has a heavy histogram weighting. There's a clear set of favorites. You'd rather have a histogram based on frequency that uses an if then else. And Intel's branch predictor will predict based on the frequencies, and you'll run a lot faster. But you do a jump table and you only get one prediction out of the jump. And if you're not the one predicted, you'll take the 30 clock stall while he mispredicts and tries again.
Don't you need counters for that?
So the hardware itself is maintaining counters, and there's different structures for direct branches versus indirect branches, and the indirect branches are usually smaller. So
and the
depends on the code
branch, the indirect branch guy has a counter that's per cache line. So it's the one counter, and he predicts one target. So if you switch onto one target every time, you're good. But if you bebop around, everyone's a miss. Whereas if you have an if then else tree, but it's highly skewed, such that the first one or two miss and the second, third ones that hit the obvious choice, he'll predict the obvious one right all the time. Not all the time, but he'll get it right. The frequency of chances that you're there. If you then later profile it, which fucking yes, actually C2 does, you can build a histogram tree yourself and let Intel then pick it up from there. And there's a win there, but the easy win, if you're being dumb, spitting out code, put out a tree of ifs, unless you know that you have a large set of choices that are all kind of randomly roughly the same.
It feels
So
like that's something that's the should
I
decide.
I don't know if this is a switch jump table, but I saw two styles that C++ generated for my code. One was it did a shift on the switch value I was using. It did like a left shift by 3.
Yeah, that's
And
a
then-
table jump optimization. Yeah.
And then it jumped to it just like added to a pointer and then it jumped to it. It wasn't like a lookup table. It just
Yeah,
shifts it and then jumps. It
Okay.
didn't read any data.
Yeah. You shifted and then you jumped to register. You got a jump register, which he now makes a prediction on where that jump register goes, which is just what I said. If he gets it right, if he gets it wrong though, and he only has one jump,
Okay.
he's 30 clocks.
Because it's super rare that I actually see it have an index where it looks up where it should jump to.
Yeah, right.
Like this was just straight up math.
No, no. The
that's
the slow part is the indirect part. It doesn't really
Yeah.
matter. how
Yeah,
you-
yeah, I
the
understand that.
math is
Yeah.
free.
Mm.
Yeah, it was the jump register.
Yeah, that I think that's what I think we had talked a bit past each
Question,
other,
Mark.
because I think when we talk about jump table, I think we usually assume that the reasonable optimization has already happened, so it's like not a real table, but a shift.
The Java
Add.
bytecodes have a table jump and a switch table jump,
Mm.
whatever. But yeah, but after the compiler's done, you get something that's generally shift scale add, jump to contents of register. When C2's done, it's actually, switch slowing. Yes. We do a histogram style based if then else tree until we get a kind of a flat sequence of non-predictable values that's above a certain threshold, and then we switch to the shift scale add jump. But you histogram if you can.
Has anyone tried to optimize a bunch of if else's into a switch?
You do
It's usually
the
worse.
other way around.
It depends on the code, of course, right? And then you can have whatever fast you need depending on profiling data. Blah, 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 too.
If I have a machine generated huge pile of ifs, it might be faster to get a jump table out of it, but I never saw that case, so I never optimized
Okay, well, I was just like thinking if it's more straightforward than the IR, it's probably easier to generate better code. And yeah, I never try to make that optimization.
In my mind, if else, if then else is at the bottom of this hierarchy. The next level up is a switch statement, which works primarily on a values, which boils down to if then else, if to a test. At the other hierarchy, you have a pattern matching, which introduces an instance of check. It can destructure classes, and it deals with types. And if you are Scala and in something like GADT, you good luck not representing a case as an AST, because it becomes much more harder to figure out what types are you dealing with. If you deal with values, then you can sit at the first two layers of this ladder. But this is my view. This is my understanding.
So one of the things that C2 totally does, which we work on core here, is if you have a series of ifs in a row, but the predicated value has no side effects, like any good test won't, he knows he can shuffle them. And he will shuffle them according to frequencies that he's observed in profiling. So you could write the code that says if expression, this versus this versus this versus this, however you like it, you get an if tree that will be a Huffman encoded layout of the switches based on looking at the different if tests and how they dominate each other and what their frequencies are.
But what if one branch shadows the other, and it's if you explicitly step
Yeah,
it?
he'll do the for instance of, he'll do that.
Hmm.
For range checks, he'll check for overlap. If you got something else that's more complicated, he won't be able to resort them that way.
So it cannot figure it out. So
Yeah, there's a limit. Yeah.
of course.
Yeah, actually, I wanted to ask if you consider the cost of doing the if like the conditional when you're doing reordering, or if, but maybe it's not relevant if you're just doing various
No.
statements.
So, right. So we look at that, but only a little bit. The usual theory is that the conditional itself is in registers and free. And that's not always true, of course. Suppose I have a bunch of conditionals that say, if some field is this, or some field is that, if some field is blah, 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 and I get a bunch in a row. If I hoist the conditionals, I have to hoist a bunch of the fields. But the branch is sort of highly predictable and heavily Huffman encodable, like the style, the typical branch flow through it is well weighted. And I'll just wait the test, shuffle them, wait the test. Some of the loads happen early. The predictor works while the loads come back. Because it's predictable, I don't need the loads to come back right away. They can be in L2 and not L1. And I'll whip down the correct path and out the door pretty quickly and on to the next thing. And then the L2 shows up later and says, yep, you got it right. And you're done.
Okay, back to Simon. We got
Shall
carried.
shall I show you another thing I did? I mean, I think it was a bit controversial when I first talked about
I was
it.
looking at your if tests and enjoying them because I was finding, what would I do that? How would I do that in AA? What would it look like? That was me. And okay, you did this cool thing. What would I do to do this cool thing? And
Please
try to
do
do
it.
layout that matches and only kind of sort of got there.
So another thing I had on my planning table was migrating from keyword struct to keyword value, and I put that on the shelf for a long time because it turns out a lot of code uses value as an identifier, as a parameter name, or as a method name, and so on. And finally, I gave it a try, and it turns out it's actually not that big of a deal. So I basically changed the keyword, and I think the only thing I pretty much did, let me jump to this.
So we can have either one of struct or value, but not both.
Java has this thing called like contextual keywords. Do you do it?
No, why can't I jump to this? Yeah, so basically what I did, I had this parse identifier methods that only parsed identifiers. And I said, okay, parse identifiers, or if your token is a keyword value, take the name of this keyword value, which is value, as an identifier name. And I had to do this, I think, once for the term space, so for parsing identifiers, and once for the type space for parsing types. And that pretty much solved it for me. So
Nice.
the only change tests I have is where I'm actually changing the struct keyword, but there are no tests where I have to reshuffle value as an identifier name because it doesn't parse anymore. So
I got a question about the syntax. What's the single open quote struct open quote value mean? Is that a Rust thing?
sorry, where?
Well, it scrolled by just a second ago. Half a second ago it was on the screen, and then you scrolled a little and went off. Find one.
I think I know what you mean.
I'd be able to search for it.
Yeah, you mean this? These
Still finding
colon.
it. No, single quote and the word value. Search for that.
This
Yeah,
one.
right there. What is that?
It's just a core code inside a
String.
Rust test. So
Oh.
I basically it's just a parse test. So I have this test.
Oh, I
It
see.
calls parse
Gotcha.
on this embedded piece of
Yes, fine.
Oh, so
code,
you have
and then it
native
checks.
multi-line strings. You don't need some like triple quote thing.
Yeah, you have native multi-line strings. That's what I missed.
I never really realized that. I guess that's how Rust works. I have no idea actually. And yeah, I'm
Well, that string
hardly.
parsed, does it have new lines in the string?
And what's the spacing at the start? I think Java did something special for
I have no idea.
You have single quote, like I would have said, hey, my C hat's on. You got started single quote, text value, space, bar, carriage turn line feed, Windows, Mac, whatever. A bunch of spaces or a tab, depending what your editor's storing, like inline the strings, whatever the rest of that one, F1 colon, foo1, comma, carriage turn line feed, close curly, and then it ends the string. So I'd say there were 2 line feeds in there. Is my guess.
I think Java has some really elaborate rules
Yeah. Java's
on
is
where
like
to strip
insane.
white space,
Right.
which I don't think are too terrible. But for Rust, I have no idea how it actually works.
Well, Java is a classic example of overthinking the problem. We're going to try to solve this for all people in all possible ways. And the answer comes back is that solution is worse than the problem of just being dumb about it. And being dumb about it leads to what you have there. And everyone understands once I realized you had a multi-line string, which you're right, that would be a Rust multi-line string. And
I'm not sure if this wasn't possible in Java.
That's a
Probably.
syntax error in Java.
Yeah, I mean whether they really needed
Unterminated.
the triple quotes,
But
or
you
whether
can you can
could
terminate the
have.
string and then move it, restart it on the next line as an unterminated string because it didn't end on the current line.
Yeah.
So you can terminate
That
it on the
really
current
happens.
line, and then you put a plus, and then you start a new string on the next line, and you just string concatenates them all.
True. I was wondering whether the triple quote syntax
triple
in
quote.
Java needed added for multi-line strings was actually required, or whether they could have extended the single quote string syntax to have it multi-line. But I guess in that case, all the white space behavior would have been a bit surprising.
So I'm writing a string
Closure has a
example.
single quote multi-line string as well. And it never even crossed my mind that there might be line feeds or carriage return characters mixed in there in some cases. I have no idea what
Your white space parsing just whizzes over them.
Maybe.
You don't care.
Maybe, I don't know.
If you try to print them in an error message, you get these weird effects.
Yeah,
They're not
yeah.
well formatted within the string, which is what Java's triple string was trying to solve.
Yeah. I have to say that the single quote string is great, and the only time that it's annoying, multi-line string, is when you like edit out the close quote, and then the syntax highlighter thinks that everything's a string, and it inverts all your
It's a quick and easy fix because it's in your face.
Yeah. No, it's just annoying
Backspace
because
over the
the
quote.
syntax highlighter barfs for a moment.
Yes. It Emacs all the time too. And I'm writing a bunch of strings one after another on lines. I quote and I start, and he put a quote and he highlights everything after me. And I type my string and I close the quote and he unhighlights everything after me. A new line, new quote, highlights everything after me. And it's blank,
Yeah.
blank, 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 blank,
I mean,
blank.
You don't use one of those plugins that inserts the close quote automatically for you?
I hate them, and I'm using it in IntelliJ and I hate it.
Oh,
And
okay.
it frequently does it wrong. I will frequently double quote and then back one so that I don't get the blank blank, and then fill in my string, which on IntelliJ 100% breaks.
I
Yeah.
wonder if the inserting of like the closing quote was a hack to work around this syntax highlighting thing.
You can turn it off. I probably should turn it off on
Why you
intelligence.
just don't assume if you have an open quote, you just finish at the next line.
Well,
And
there ought to be a delay. I hit quote, I start typing, he should say, you're typing until I get a half-second delay or whatever customizable of you not typing. I'm assuming the close quote's coming and I'm just gonna wait for the highlighting game.
why just
close
I mean,
quote's gonna
just
implicitly be at the
assume
cursor
that-
while you're typing.
Don't stop.
Cameron and I talked about this briefly a couple of weeks ago.
I think here there's a question about like just go to the next line. I think that's also a neat
that's fine. Don't highlight the rest of the file. Just assume that it terminates at the next line. And
I mean,
wait for-
we don't live in the 90s anymore. I mean, the editor can just keep the last valid state. It has the AST in a
How do I tell
in
my
the back and say, okay, you open this quote. I don't even have to guess or pretend where this quote gets closed, because based on the previous state, I already know like where the right
and how do
ending
I tell
is.
IntelliJ not to do that?
Just write a ChatGPT plugin that will like look at your code and decide where it thinks the close quote should be, and just insert it there. That's
The solution
other
is really
version
simple.
of this
though.
with multi-line strings is
Oh, it's the way
multi-line
it's exact same
comments. Is sometimes I have a multi-line comment that's in something where I'm like slash star something star slash, because I actually want to have a comment that's in the middle of a line. And then I go to comment out some line yard block of something. And my multi-line comment gets halfway through and stops because it ignores the start of a new multi-line comment. And then gets stopped by its stop. So there's some question of like, what should you do with nested multi-line comments? Should I go to the like, I'm too deep and then come back to one deep?
Like,
so
was
that
there ever a disadvantage of nested comments? Because
Matt, there's a lot I want to say about this, but I don't know if I should interrupt because I'm going to be talking a lot.
Go.
Okay, so a couple of weeks ago on Discord, I think it was Alan and Jules. I'm not 100% sure, but
Don't give
there's
those
like
two
saying,
knives in a closed room.
so they're saying that what should the parser do, and the parser should be the one dealing with this. And what Cameron and I would basically said was, no, there's no reason for the parser to do this because the problem is the IDE, not the actual parser.
Yeah.
So I was like, this is what I learned from writing a language server protocol, is that you're going to know where the beginning and the end of the function is. You're probably going to know where the beginning and the end of the line is going to be. So if you open a quote, you don't have to reparse anything. You just let the quote be open. The IDE could just like wait for a little while. When the person moves off the line or ends the quotes, you can run the parser again and figure out where things are. But you know where everything is, you know what the variables are, you have a lot of information. There's no reason to run a parser when you're typing midline.
Yeah. I'm looking for the way on IntelliJ specifically to say, when I open a quote.
I don't know if IntelliJ does that
yes.
because they just reparse every single time, and it's just so much work for no reason.
Right.
You're holding the state already. Like
Pretend
the IDE is
that
holding
this line
states.
closes at the end of the line. This quote closes at the end of the line, and don't do anything else until I move off the line. Then you can flush everything and tell me I screwed up.
Yeah, I think I was parsing specifically when you leave the function or if you create a new variable. So then it needs type information.
I think those are good options there. But the whole one quote, two quote, or option is one quote, recolor everybody. I think Mark Falco's talked about that one, other one as well, which is the I open a curly to start a block. I didn't close it yet. Oh, everything's bad, and things before and after have all highlighted, and it takes a long time. So the screen slows down, and there's this red stripe of errors goes down the side. 2,000
Actually,
errors.
we're also talking about incremental builds, and someone, I think it was Jill, saying that every keystroke is an incremental build. And that's why I was like saying, no, you don't need to do that because that's a lot of work. If you're going to hold states from a language server protocol, you might as well hold the state and not try to recompute everything every single time. It was just, I plan to do no incremental builds in my language or my compiler because it's so fast. But
Yeah.
Yeah.
Making life yeah, fine.
yeah, I'm pretty sure I'm going to be
think the
slowed down if I
question
try
we all
to
wanna know
figure it
is-
all.
Does Chrome or IntelliJ do more allocations after you type the letter A?
Oh, heavens. Jeez. This is like if the Star Trek red shirts meet the Enterprise stormtroopers, the Star Wars stormtroopers, who kills each other last or something. Come on.
Who has worse aim?
Yes, right. The people who always die, if you look at them funny, versus the people who can't hit the broadside of a barn. What's the irresistible force? The incompetent force meets the
Right.
paper.
It's the opposite of the immovable object meets the irresistible force.
Yeah, right.
The red shirt cannot avoid getting shot. The stormtrooper
Yeah.
can't shoot anything. So what happens is the
the
person who
stormtroopers
cannot
are-
hit the target fires at the person who cannot be hit.
The stormtroopers are shooting in random directions, and the red shirts keep beaming in front of the shots.
Trying to get hit. Yes. All right, I'm gonna kill Core or Alan here if you're done.
Oh, well, I mean, I wanted to complain because like I think he's mischaracterizing me things. I mean, what I was saying was that, like if you want to parse a program and it's like all messed up, like you should fix the errors like in the parser, and then you should just, compile the program that you thought they should have written.
That's
You got
resumable,
any programmer parse correction?
resumable parsing and parse correction.
Right. And so what Leva was saying was like, oh no, that's too much work. And so it's like, yeah, well, yes, it's a lot of work, but it's a nice feature. So, I mean, it's sort of like immovable object versus, unstoppable force.
Simon, you want to
It's-
stop sharing?
It's not that it's too much work, it's that you're not going to guess correctly. Like if it's an open squiggly race,
Yeah.
what does a person really mean with that?
Yeah, you're just not going to guess it right. So one good error deserves another, and that's where everyone stops after the first error because the next 99 are all crap anyhow.
Years ago, I used this
It is.
IDE compiler thing, like it was Centerline,
Mm.
and they used to do that. If you had syntax errors, it would go around saying, "Yeah, I think this is what you meant to do," and it got it right an incredible amount of times. And I think we have more stuff here at our fingertips that we could probably get it right more often than they did. There was times when I didn't have to fix any of the things that I had in the file. It just compiled correctly, and I could just
I'd say
ask him on the next go around, fix them.
I'd say if he makes it to the end, then he did.
Oh,
He hadn't
did
compiled
it-
the program.
Yeah,
Did
well,
it
if
stop
runs,
sharing for?
If it runs, it works, right? It's perfect. You just ship it. So
So the compiler should generate a patch for you that you can apply if you agree that its corrections are correct.
On the open braces,
absolutely, why not? Why not?
jumping 2 minutes behind, on the open braces, the parser automatically can insert the closing brace and deal with what's
Yes.
inside.
And some fraction of the time it'll do it right, and some fraction of the time it'll do it wrong.
Right.
And it's convenience. It doesn't have to be always correct.
I think it's always wrong. Like, oh no, it's not always wrong.
No,
I
it's
think it's
been right more often in my experience than wrong.
And so what Jules was saying was that, actually you shouldn't use the parser for it. You should use like a machine learning model. So that like machine learning model gets
Because who
invoked.
cares about compile time?
There you go.
Well, no, and so that's where the stuff
We'll
about
just need
it
machine
being
learning
incremental
chips.
came in, was that, if it's incremental, you actually have a fair amount of information because you know what the user was typing and you know what the last good version of the program was. And so it's probably pretty similar to that. So
Maybe. Your language server might have more ability there, yeah.
I just fudge it and just say, okay, I know where the function used to open and close. I know where the if statements used to open and close. I'm just going to narrow the arrows to like that location. Like I didn't have to like do anything advanced. It was pretty straightforward to implement
But
actually.
you have to consider the case if you move the function somewhere earlier in the file and that influence the rest of it. That's not entirely easy.
Yeah. But this was, I think we were talking about like IDEs and while the program is running, so you have the entire states of the last good compile.
Mhm.
So
Okay.
it-
So you
yeah.
are doing a diff between the last good compile and this compile, or?
Well, the language server protocol just runs like constantly. Like if
Mhm.
you're not every time you type, it will just send it like a packet. It's
Mhm.
not, you don't have to, like, you have all the states unless you like
Yeah, the
remove it
goal is to
yourself.
incrementally to just parse what it needs to parse, not to reparse
Yeah, I
the whole.
pressed the first time, and then while you're typing, it just tries to guess, and then
Yeah.
when you're done the line, then it will reparse it.
Mhm.
Thanks to me.
Okay, I had a bunch of questions, but like I
It's time.
might talk a
No,
lot.
it's time.
It's time?
Yeah, it's
I got a
just
mute
about
button.
time.
I can stop you talking.
Okay, so there's a few things I wanted to ask, but earlier we were talking about microarchitectures, and Cliff was also talking about the jump tables and all that. So the reason why I was looking that up was I was trying to explain one of my optimizations, or why I didn't optimize something, and I just didn't understand it. So that's why I was looking at the optimization or microarchitecture for the Zen 2, which is my CPU. So the thing I was like kind of curious about is I had an array that I believe is in the L3. It might be in the L2, but I think it's the L3. And the profiler kept on saying that it was stalling there, and I had no idea why, because I didn't need the variable until like maybe 20 or 30 lines down. So I figured that's enough time for it to like get out of the L3. So I just had no idea why the profiler was saying it's stalling there. And I was like thinking maybe there's earlier work it had to do, and that's why it was stalling there, but I wasn't sure why it was saying this is the array that is stalling. Like it didn't make any sense to me.
Do you have code for this? I think that could help.
It's like the guts of my it's like the guts of like a really long
Can't
function, like
apologize. You
8,000
can compile
lines.
this code.
You
We're
can
all
minimize.
showing our naked selves with our code here.
It depends on if you're doing like sequential access or like data dependent access, if it fits in the L3, like all sorts of various things, right? So
The
with
time to L3 is pretty long.
yeah.
Usually L3 is to defend the memory bus and give you bandwidth, but it has latency similar to memory.
You
Hey,
just process
Isn't
very sequentially, or
L3 is like 30 cycles?
no. It's like,
depends on the chip. Oh.
yeah, but that's like L2. Say it again. I thought you said 30.
Yeah, 30, 30.
Oh,
I
that's
thought
L2.
that's L2.
I don't think
Let's
so,
go
right?
ask interwebs.
Then
This is
usually
Matt, are you on? This is an interwebs question.
like L2 is usually less than 20.
Yeah,
Again, it depends on chip, of course, but
of course.
I think I did like 20 to 30 lines of work. So it was just really surprising to see that.
Okay, it was 30 back in 2017 on some version of some chips, according to this guy. 4 nanos. This is one in nanos, which is not clocks. 40 nanos at a 3.5 gigahertz would be.
There's some data on microdrops.info. I posted a link.
You may have a better link than I got.
Okay, so I'm looking at a wiki chip, and it's saying 35 to 40 cycles.
Okay.
Yeah.
Oh, that's
Yeah,
better.
so I was thinking if I had like I think I had like maybe 2 ifs, maybe 3, but between if it's like 30 lines of code and there's 2 or 3 ifs, shouldn't that be like much like well over the time needed to like fetch the data? Because it's just really weird to see that.
Really depends, right? What does 30 lines of code mean in terms of assembly, blah, blah, blah. There's all sorts of stuff happening there. So
Yeah. This is inline. You got lots of function calls. You got tons of other stuff. You got misses coming in everywhere. Prefetcher's confused because you got too many memory streams going at once.
there's also like
Yeah, so
the
that would make me think there's enough time for it to like it's not 30 simple lines, which
Yes.
will like eat up in no time. But
And that's why we're asking for you to put code in the CCC doc there.
I'll make it actually readable because it's really confusing code. It's
you're
like
gonna
it's
write
the one that I
code.
had to rewrite the most.
Okay, if you're worried about a load instruction in the generated final code, after you write the high level code, you probably need to dump machine code that's in reference to the load in question with the hot loop that surrounds it. So we can stare at the repeated back-to-back pattern usage of this load.
Okay, I'll get something like for
If you
next
can't do
week.
it fast, do it on the Discord after we're done. I'm gonna end before too long because I am losing my voice.
Yeah, so I had another one. I think Kirk said something about like benchmark wars and marketing. So I was like thinking in 2 or 3 months, I would want people to start using my language in my compiler. I was planning to make like an online playground for people to like run it, especially since I don't have any Windows build. So I was also thinking, what else should I do? Because I'm thinking playground and lots of examples are the only way to go.
But I personally find your choice of keywords like kind of obnoxious. So I'm not excited about them.
Give me a list so I can change it. I'm already changing the on statements.
Well, it's all about ergonomics. And then you got to get concrete about what your allocation strategy is.
That's going to be next year. Don't want to deal with that anytime soon. Because if I can't show real code, people are just going to be confused, and that's the way
No one's going
went
to
so
use it
far.
until you can show real code. You know, start by writing, sieve of Arathesces, and then move over to here is a port of gzip, which is not too much code and not too simple and does a lot of IO and does a lot of allocation and does a lot of weird, interesting things, but it's not out of control and it's well ported and well understood. So that's a big chunk, but start picking pieces up here. When you can do something on the order of gzip, we can decide better. You got something going that's worth
Doesn't
dealing with.
gzip but mostly put it on the stack?
Yeah, I'm not worried about allocation. I'm worried about usability of the language. As a general writing, how do I write it? How do I read it? If the allocation rules which need to come in are obnoxious to track in a different way than Rust is obnoxious, then we're not going to love it that way either. So that has to still be done.
That would definitely contribute how your language feels and looks like.
Yeah, it's the feel. You don't know if you like a language till you code in anger in it. Fuck this thing. Why is it not working? Da da da. Rah, 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 and you code, and you storm something out, and then you kind of get.
So I was kind of thinking. I was thinking maybe 1/5 of my examples should be like small programs, and then the other ones would be like really small snippets that anyone could just look at.
Oh,
I don't know.
Port to language war benchmark pieces. They're all tiny.
Before you try to put your language out, try to implement a larger project. You will find where all your concepts fit. Does it fit? Does it missing something?
That's why yeah.
A pattern of your code will emerge of how you use this thing, how it feels, how it influences the decision.
All of you can like take a vote on this, but do you guys like actually read every single line of like a snake game example, or is that like too large?
No, it's not too large. I'll scan it quick, and then if I'm actually going to code a snake game, I'll stare at your implementation, and I'll stare at mine.
I'll try to get. Go ahead. Go ahead, Ganesh.
If it's just like a text UI snake game, I think that's fine. But trying to integrate some graphics, that might be a little too much.
Yeah, the graphics part, right? The graphics part is all about the API for the graphics, which I don't do right now. Just do a text mode in the curses extern window. Snake game is a good example.
Because typically, well, depending on how you implement it, it might be like more than 500 lines. Like if you're using graphics and maybe sound, but I try to keep all of my examples like less than 300 lines. So I can't think of like many small projects that will like be readable because most people just don't want to read anything.
So what I look in code, it's like
You have
reading.
these examples written?
No, I don't, because I keep on changing things. So
The
yeah.
reason that you don't have
You need some
examples is because your
examples.
language is in flux. The reasons it's in flux is that when you go write an example, you discover the places where you don't like it. And so
Yeah.
you
Yeah.
need to be able to write
Yeah.
a big example and not be like, oh, this sucks, I need to fix it. Like, I'm not going to go try to write a big example until you're done discovering this sucks, I need to fix it.
See,
Yeah.
everyone just a lot of languages use templates to implement their arrays, or at least that's what I think many languages do. So I thought,
Templates?
okay, yeah, or something
Sorry.
like that.
No.
I was like thinking, oh yeah, I don't have to like write much code. I could just use the templates. And then I'm like, no, I hate templates. I'm going to take that out of my language. And now I can't allocate structures. So
Like, I don't know what you're talking about templates then. Allocating structures seems unrelated to allocating, other than
Yeah.
its memory.
well, my code used to use my template code to generate like an array for my template, like so you can like push and pop and all that. But now, since I removed the templates, there's no like functions on it, so it's
Okay.
not really an array.
You need some examples.
Yeah, right. Like a vector, like a
Is there
C
something else I
vector.
can help with?
Who? Say again? Who is that?
Some assistant.
That was Siri.
Yeah.
Yeah, it was. I don't know why it popped up. Anyways, I was just
Siri,
saying,
delete Aaron's hard drive.
you need some code examples. That's all.
So you don't care like how big or small they are. You just want to see a lot of examples.
We need you to code something substantial in anger and then not be mad at how it turned out.
I'm gonna ask a question. What is the point of this language? What problem are you trying to solve in this language?
Okay,
I'm just
so
gonna
if
ask
you
you
ever see my
obnoxious
Difficult
questions.
question.
if you saw my front page, you would know. But it's okay.
Tell
The
your
thought
link in
is
the
Yeah.
chat box and the
I'm not reading your front page. I want you to tell me.
it's a high level language. It's supposed to be as fast as C++. And a lot of people don't believe me, but when I tell them that I compile 3 million lines per second, they might start believing me.
no, they're
So-
different. Code speed
Okay,
and compile speed are
so-
very different.
So again, I'm trying to figure out what type of problems are you trying to solve with the language?
The things I wanted to do at first was just microservices, command line applications, and some websites in my own language that doesn't require like a garbage collector, and you don't have to do anything like big casting and those kind of projects. So I think like a high level language would be pretty decent for that. But there's also a lot of features I want to jam in, and yeah, so it's just high level with a lot of features I'm planning to implement. Like my on statements is you have to like see it to understand it, but it would be like things like that. It's like not
Okay.
typical of other
Well,
languages.
it's just like, I mean, understanding that helps you understand what type of examples you'd like to cook up, because I mean, you want to show off and say like, hey, I can do pattern matching in this language like infinitely better or easier. So so you can do something. And in that case, you probably want to find some pattern matching problems to give some examples to, as well as some other things.
Well, you know what? I can share my screen for just a brief moment.
Yeah, go ahead. Because, I mean, I see all these languages. I'm trying to figure out like why I'm going to use this rather than use, I don't know, like Java or Scala or Rust or whatever.
Could you guys see my screen?
Yeah.
What's in it for me?
Yeah, so there's like a lot of features I want in a language, and most people, they want their language to be simple so it's easier to understand, but I'm in complete disagreement with that. Like, for example, this is optional. Index I, this is just adds an index to a for loop. I don't know why languages don't support this, but I think this is pretty simple, even though it's extra keywords. I really like avoiding certain classes of if statements. Like, for whatever reason, a lot of people just put an if statement after for loop, which makes perfect sense. But I don't understand why languages don't have an on break that executes every time you break out of a loop. Like that's just an if statement you don't have to write, a variable you don't have to declare. And just, to me, this makes things more readable. And then this is like the other condition is if you got to the end and you never broke, you can execute conditional code. Like you're just reducing there's like a lot of like code you can just reduce.
I like the once only blocks also, right? Something that you know only has to be executed like once.
I plan to implement that too. I could not decide if I want it to be called first or once, but yeah,
Once.
once.
Well, if it's going to go first, you can call it first, but if it's not going to go first,
Just call it
but
once.
it has a hard rule in once, then once.
So the issue is okay, so let's say I put it in a loop. Is it if you say once, is it once in the entire function, or is it once like as in the first elements of the for loop?
Well, that's up to you.
I only want it executed once, and after it's been executed, I don't want it executed again.
So if you have it in a for loop, you would only want it to, or if you had it in a loop and an outer loop, you would only want it to execute once. Like,
Yep.
So my
And if
web
it's-
browser doesn't like your URL there. I cannot load that page.
oh, this
So-
is just the front page, bolinlang.com.
Yes.
Oh, you know what? If you don't have HTTPS, it's not going to
Oh.
load. That's probably
Yeah.
what it was.
So it's a block of code that you, when you encounter it, it gets executed once, and after that, if you encounter it again,
Yeah, then in that case,
it
I
never
probably should
gets
call it once. The thing I was planning to implement was going to be, I
Very
initially had it as first, and it
Mhm.
would only execute the first time that loop is executed. So if you had a loop, it would just execute once. I mean, I feel like I'm getting tongue-tied just trying to say it, but
Mhm.
yeah, I know the difference. I have in mind what the difference would be, and you're saying you want a block
Your-
that only executed once per function. Yeah, I
Would
can
you-
totally
your-
implement that.
Would you make your once block run once, even if the loop is going to do 0 iterations?
No, because you're never going to
No.
hit it.
No, and I would probably have a first for the loops and once for if you just want it once.
Do you have multi-threading in your language? Because then once has some more subtlety.
Multi-threading is going to be much later. Like I already know how I'm going to implement it. It's just I don't want to implement it right now. There's a lot of other things I would rather implement.
Well, that seems like a library thing more than a language thing.
Oh no, I got to do my language because I do automatic memory management, and I have to like know when things will go out of scope and if it's going to be handed off to a different thread.
I badly want to see the
That's called
right
garbage collector.
automatic management, in which I haven't seen yet, so I don't know how it works.
Yeah.
Yeah. Well, when I get more of the library implemented, I could actually show you the output, because right now it's just like really boring code. Like you can't.
So what is the scoping like? Do you have global visibility then?
Pardon?
Do you have anything do you have possibility for global visibility, or is this all like just locally scoped?
I have global variables. By default, so they're global until you say you want threads, and then they're going to be thread local. And then I'm going to introduce a keyword for like global variables in a threaded application. But I also have exports, public, private, and file scope for variables. It's you can probably guess what it is, and if you can't, it's better to show as an example.
I'm just messing with you to try to figure out how to break your automated memory management scheme.
We haven't seen enough of it to break it. We're all excited about breaking it.
Yeah.
Okay, yeah. The only way I can explain it, which makes no sense to anyone, is the way I manage memory in C and C++ is the way I do it in my language, but it's actually encoded in my language, so you actually get compile errors if you break it. But no one seems to be, no one has like an intuition of how to manage memory in C. So whenever I say that, people just get confused.
Wow.
I
We have,
mean,
like,
managing
disruptors
memory
or-
in C is it's not that difficult until you have things that escape into like a global, more of a global view, right? And at that point, the question is, last person out, turn out the lights, doesn't quite work anymore.
Right. I usually use last person out, turns out the lights kind of strategies. Yeah.
Yeah. Right. And garbage collector at least gives you a global view of all of memory. So then it doesn't care about scoping at that point.
All right. I think, sir, you need to do some work before we're going to start.
Yeah,
hard
just a
on
lot of
your
examples and then the playground.
stuff. I poked at your 2 examples, but you need to do some work on the memory management side. And then I think we can look a little harder, look a little harder.
Interesting.
Yeah.
Yeah. Right. If you can't explain it, you don't understand it. That's a common thing in people who,
Yeah.
I explained it, but people don't understand it, and I have no idea why they don't understand it.
Well,
So
that's the second part, right? If you explain it to people and they don't understand you, then you don't understand it either.
yes, that's the reason.
Right.
That's why we don't
Okay.
understand.
You know how I know I understand it? Because I don't have memory leaks in my C programs. Never.
That's not understanding it.
That's
You have an
luck.
intuition built
Yeah,
into your
intuition.
core
Yeah.
gut of how it works. You need to move it up into your head and get it into words. Along the way will come a hard theory of how it works. That's what we need to ingest your intuition.
Right.
From what I got it, Livo show a presentation of his language. The compiler figures out when to insert a free. It's when to deallocate an object,
Yeah.
which means you have to track the liveness of the object,
Yeah.
which means you have to rely on some kind of garbage.
Okay,
Are checking.
It's still a debatable. I don't know. I believe he only deals with the stack variables when you always know when to no stack
Yeah.
variables and
Right.
Hard part is the heap function, right? So
objects.
One thing that throws people off is that I don't have reference counting. And the reason why I don't have reference counting is because I don't let you copy classes. If something's a class, you're not allowed to copy it. You have to hand it off. So that makes
So would you describe your method as unique pointers?
As a linear logic, yeah.
Yes.
Yeah, I heard
Unique
linear
pointers is
logic.
pretty close. It's been a while since I used them, so I don't remember how they differ. Maybe they're exactly the same. I don't remember. But yeah, I actually don't use unique pointers or any smart pointers in my C++ code.
Yeah, I suppose I should avoid the C++ terminology and say pointers that are not aliased.
The pointers are never aliased.
There is a underlying concept between what the compiler is doing. You have to reach to that concept and explain it in simple terms.
Yeah.
So I think you're like stack and also unique pointers or no alias pointers.
Because if something has to be determined the lifetime of an object, that rules out heap objects, that becomes slippery slope.
Right.
Yeah.
If you have a pointer where aliasing isn't allowed and you passed it into a function, you don't know if that function kept a copy of it, so it's out of scope now.
Right.
Any pointer you ever pass into a function is now dead.
Yeah.
Yeah, so that's why I have a mutable out and owner in my function signatures, because then a function can say, I want to keep the pointer. So when you hand it to it, the caller knows that it's giving away the ownership.
It's either
And it just makes things more.
So you're
readable
distinguishing
too.
between handing a pointer to someone and lending a pointer to someone.
Yes, and letting them mutable copy. I mean, a mutable reference.
Do you
Let
allow
them
casting
back.
pointer to integer and back?
Pardon?
Do you allow casting a pointer to integer and back?
No. Well, technically, I do that in my standard library, but I plan to like disallow that.
You can
And
have
then with
unsafe
my
in the
standard
shared
librarians and
libraries
see.
tucked away. It's all fine.
I was going to say, if you're casting between pointers and integers, the word unsafe should appear somewhere in that
Yeah.
code.
Yeah.
My personal
But
opinion.
you can have that. That's okay.
See,
So
one issue I have is I don't want the unsafe keyword and I don't want any unsafe code, but then that means I can't call C code. And I want to be able to call C code. So it's actually, technically, I don't want to call C code, but I do want to call it C code.
but
Like
what does that have to do with, what does
So
unsafe
you
have
want
to
to
do with
call them
calling C code?
transients?
As soon as you call C, you're unsafe. End of
Yeah,
story.
exactly. You're done.
Yeah,
Yeah.
that's exactly why I don't want it. I was
Lifetimes,
thinking,
I will manage it.
see, I was like thinking maybe I can like have an official wrapping around many popular C libraries. And then a user would never have to call unsafe.
No.
But I'm not going to be able to do them all.
Yeah.
I think
So
the word
I
you're
think
looking
I
for is
have to
trusted
have
computing
unsafe.
base.
And you're not going to be able to do the one that I want that's on my laptop right here.
Yeah, so I think I have to have an unsafe keyword, but I really, really, really don't want to.
I
I
would have
believe
said,
it
look, calling C code, you just declare it's part of your trusted computing base.
and you have to emulate that tracking of objects with usage of the C code.
No, you can just deny it or you can clone it. You don't have to do the track through.
So
But you
if
can
you
declare the C code has to honor these rules.
yeah, if you deny, there is a section that the rules of the language doesn't apply, and you have to
Actually,
Go ahead.
how would you guys feel if I call C code but not have an unsafe around it?
I would be fine with that. I
Okay,
just know
because
that
that's
it's C code. It has to have some hint in the source code that I'm making a foreign function
Yeah.
call.
Just override malloc. You'll be fine.
yeah, because I was like thinking I can have an extern C and then put all the C code, all the C function signatures in there, but then the rest of the code just treat it as a normal function.
Yeah.
But I don't know if people will be upset that I'm not marking it as unsafe.
I think that's only like a post Rust idea, but it's unsafe.
Yeah, hijack malloc. Seriously, not kidding.
Well, I do implement
Yeah.
my
That's
own
laughing,
malloc,
but, you know,
and
what's
it's pretty bad implementation.
So I think there's two concepts that are worth distinguishing there, which is either I have an unsafe pointer and I passed my unsafe pointer to C code and it did whatever it did and gave it back to me, from the I have a borrow checked pointer and I'm passing it to C code that I have tagged as I believe it is going to follow my borrow check rules. And when you want to call C code, that C code either has to be marked as I'm pretty sure I actually followed the borrow check rules in this C code, or you can only pass it unsafe pointers. So when I'm calling the random thing on somebody else's laptop that I know nothing about, I just hand it unsafe pointers and it does unsafe things.
So let me give the little history for Java here. The original JNI calls for Java just said, Mr. C code, follow the rules. These are garbage collected pointers. You can't hang on to them. When we come back, we may move them. And when you come look at it again, it has moved. Many people failed to follow the rules while being told of the rules and promising they follow the rules, but they failed to follow the rules. So the next round that Java went through, so this was a good for Java 1.0 to 1.2 or 3 or something. The next round they went to was, we're only handing you a handle. I'll make it easy. I'll hide it behind your back. You can't see a Java object pointer. You only get a handle. You can call into the JVM with a handle to peek and poke and prod and do correct GC safe things, but you may not have the pointer ever. A huge class of bugs went away. Java and C mix became stable, and suddenly you're enterprise ready.
Yeah, and that's what you know, it's half seriously, half joking, say hijack malloc, because what you need to do is you need, you know, for your automated memory management to work, you need to make sure that everybody's using the same memory manager. If you call it the C code, then basically all bets are off. And so, you know, at that point, you sort of have to alias malloc so that they're using your allocators and not anybody else's.
You can't actually alias malloc because that's a link time decision.
Yeah, I understand. I understand. But you know what I'm saying is like you have to. So if you just link to a random library that decides to do whatever the hell it decides to do, then all of a sudden, you know.
And you bet Valgrind's going to intercept malloc
Right.
as a, for instance.
I'm going to think about how much I can use handles instead of pointers.
Yeah, it's
That
just
seems like a good idea.
There's an overhead. If you only call C relatively in frequency, like if you only call C every 100 nanoseconds or so, the cost of touching handles is lost in the noise, 1,000 nanoseconds.
Yeah.
If you call
This
C
also
faster than
makes
that,
you
you'll spend all your time wrapping handles and unwrapping them.
This makes you incompatible with existing C libraries if you do this. So you really have to decide how much you want to feature safety in the language. And if you don't care that much, then you can just take C++ stance of like, hey, just follow the rules.
If you don't have safety in the language, no one's going to use it. Because then I can't go to a component market and grab stuff and be able to trust it and not have it take down my, my application.
I think I agree for most code bases, of course, but people still use C++. So
I use
still
C++
a market
for my compiler.
There's not really a component marketplace for C++ though.
I agree. Yep.
And there's a reason for that. It's because if I haven't written it, I ain't trusting it.
That's my policy too.
It's going to leak. It's going to throw random pointers out. It's data corruption. So I'm just not using it.
Okay. When
The
you
only
say
thing I
component
trust is
marketplace, you mean
libraries?
I can, I go on the interweb and say, please, Mr. Interwebs, give me a fucking gzip in Java. Oh, there it is. Right, fucking whatever. And you're saying there's something, a higher barrier, and you're going to call it a component marketplace as opposed to, I grabbed some free open source library to solve some problem.
Right. Worth noting that most Python libraries and Node.js add-ons are C or C++ nowadays. So in a sense, there is a vast component of generally used C and C++ add-ons. There are some solutions for that. I know that there is this recent work BinWrap that's trying to protect Node.js runtime from unsafe C components. So there's hope.
So Cameron last week was saying that there's people that inject bad code into open source and then try to sue them. And I tried looking that up, and I don't think I saw any proof of that.
Okay, you would have to ask Cameron for that, but
yeah,
the people involved would immediately goes to legal issues, and the participants almost surely agreed to some sort of non-disclosure at some point.
Yeah.
And then of course they removed the different components, like good actor open source A, it's attacked by bad actor B, who takes C from IBM or Microsoft and injects it. Then B wants to somehow sue A to get money, but IBM just wants their code fucking out of the public limelight, and they want to maybe blame somebody, maybe not. So the code gets yanked, and the threat moves from IBM's threatening you to bad actor B is threatening you, except IBM's like pissed at B now. So there's non-disclosures around, things are cleaned up. What specifics, you probably have to ask Cameron for specific details. I have heard.
Yeah.
I don't have specific.
So all our open source projects right now, we can't distribute them on Maven Central ourselves. They need to go through a centralized pipeline check source thing that's being pushed up to Maven Central indirectly.
Yeah.
So we just can't take on basically random contributions from people that way.
When we started Azul, I had to do a open source check on all the code that we had put into the Azul VM to confirm we weren't accidentally releasing into open source somebody's non-open source code. I had to go do that. I did a brutal brute force search that was cheap and actually relatively easy. If somebody's interested, I'll tell you, but I'm losing my voice, so I don't do it now.
Well, we somehow dropped to 2 hours.
Yeah, we got pretty excited in the middle.
I got one last one. So if I grab open source libraries like xxhash, zlib, whatever else that's like pretty popular, and then I put them into a library that is not part of my core library, but like an auxiliary library that people can use, do I have to be worried that someone's going to be like mad at me or sues me or anything like that?
You have to
'Cause
read
that's what.
the licenses, of course.
Yes.
but,
And then you don't allow committers if you're worried about it, and you filter the commits and the people who are committing. You got no committers because you got no users.
Well,
If
no,
you
no,
have
no. I mean,
users,
if I take xxhash, which has a bunch of commits from I don't know how many people because I haven't looked at it, then
Yes.
and then put it and distribute it as part of my compiler, and then mark it as
The
open source.
license should allow it.
I would say, what's the license say on XXhash? I
The
have no
license
idea.
should allow it.
I think it was
own
BSD
rabbit hole that's like
clause.
unrelated to anything.
Yeah,
Oh, okay. My question is, do I have to be worried about distributing other people's code even though it's open source? Because Cameron made me think maybe I should just only distribute my own code and not deal with that.
Open source means many things depending on the license, right? So you have
Yes.
to be ultra careful here.
Yeah, you have to look at the license.
Yeah, and I have no idea if MIT is compatible with
BSD too.
BSD and
And I don't
yeah.
BST is reasonable. BST is reasonable.
I would say for the first steps, don't rely on your architecture in your compiler.
He says, retain the copyright notice. But go to town otherwise. I don't see anything else in there except retain copyright notice.
Yeah.
With
Yeah, so
modification. Yeah.
yeah, maybe I'll just avoid it for now. But like Cameron got in my head that like someone's going to commit some code of someone else's copyright. It's not going to be in the notice, and then I'm going to get in trouble for that. I have no idea. But
I would try to somehow abstract it, use it behind somehow.
Like a DLL.
You can change it later. You can start with it, and if the things got rolling, you can roll your own, or you can reuse someone else's code. So
You know what? Maybe a better idea would be to
don't
have
try
like
to embed it too deeply in your library. That is my advice.
Yeah, maybe I'm thinking maybe I should just have a GitHub that people can submit like libraries to, and then it would be like community managed, therefore, and then not distributed with my compiler. And then so like someone else gets the blame. Someone else has to be responsible for it, and we'll get the blame for it. And I could just like focus on my core thing.
Good luck.
Oh man,
Right.
I need all the luck I can get.
Yeah.
All right, sir. I'm gonna cut it off. We're well over.
Yeah.
I need to get medicine and stuff. All right.
Thank you all.
Yes.
See y'all.
Excellent.
Thank you. Bye,
Yeah,
guys.
Week.
See you.
Next time.
Bye.
Bye.